Okay, we're now going to go over notes number 14, which is quadratic functions in the standard form. The standard form of a quadratic function is ax squared plus bx plus c. There's a lot of information that's given to you by your variables or your coefficients a, b, and c. So you're going to want to get in the habit of writing down what your a value, your b value, and your c are, so that you can use them to determine various parts of your quadratic function. Okay? If the a value is positive, if it's greater than 0, it means your graph, your parabola, is going to be pointing upward. Okay? So anytime that a is greater than 0, your parabola points upward. If a is negative, it just means your parabola points down. Okay? So when a is less than 0, it points down. The equation for the axis of symmetry is x is equal to negative b divided by 2a. And all the axis of symmetry is it tells you the vertical line which your graph has. Okay? Next, we're trying to figure out the coordinates of the vertex. We want to be able to calculate where the minimum of the curve is or where the maximum of the curve is. That's called the vertex. And the way we do that is we take our negative b over 2a, which we just calculated. That's our x component. We then take the function evaluated at negative b over 2a. So we're going to take our x component, plug it into the equation for x, and solve for our y component. Next, the c value tells you where the parabola crosses the y-axis. And then last, which we did on our last homework, you're factoring the equation, the quadratic equation ax squared plus bx plus c, and you're solving for the roots of the equation. Okay, now we're going to work on example number 1. Hopefully after we go through this will make a little bit more sense to you. First thing we're going to do is we're going to look at our function and we're going to write down our values. We have a is equal to 1. Okay, remember that if there's not a number in front of the variable, it means it's a 1. We have b. There is no x component, so b is equal to 0. And then our c value is equal to negative 9. Now that we know what a, b, and c are, we can go ahead and plug it into the equation for the axis of symmetry. And what that is x is equal to negative b divided by 2a. Take our information. Negative b, well, that's 0. So we have 0 over 2a, which is 2, and that's equal to 0. All that tells us is that our axis of symmetry is the y-axis. Next, we want to calculate our vertex, and the way we determine our vertex is the x component of our vertex is negative b over 2a, which we just figured out was 0. And to figure out the y component, you take your value that you just determined for the x coordinate and you plug it into the formula. Well, when we plug in 0 into x squared minus 9, we get 0 minus 9. So the vertex is located at x 0, y negative 9. So I'm going to go ahead and draw some points. Here's x, and we're going to come down 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to put a point here, and that is where our vertex is. We know from the a value, that's 1, that the graph is going to be open upward. Next, we need to write down what our y-intercept is, which we already know from this equation. C is equal to negative 9. So the vertex is 0, negative 9, and the y-intercept is 0, negative 9. Next on the list, we need to find our roots. And the way we find our roots, we set our equation equal to 0. So we're going to set x squared minus 9 equal to 0. Okay. The easy way to solve this equation is to add 9 to both sides, and you get x squared is equal to 9. You take the square root of both sides, and you find that x is equal to a positive or a negative 3. So we're going to write down the coordinates for the roots, and they are at 3, 0, and negative 3, 0. All right. We now have our two solutions, so we're going to go ahead and put points on our x-axis where our solutions are, and we have 3, 0, and we have negative 3, 0. We now have 2 points. We can draw our curve, our parabola, I should say, and it opens up, all right, and going in this direction, it goes up this way. Based on this information, we can look at it and we can decide, or we should be able to see, that our domain goes from negative infinity to positive infinity. Remember, we use parentheses because we don't ever get to infinity. Our range, we start at negative 9, and yes, negative 9 is included, so it is in a square bracket. And our graph continues to go up, so it goes up to infinity, and we use parentheses. So there's the graph of the parabola described by the equation x squared minus 9. The a is positive, so therefore the graph is pointing upward. We calculated our solutions to the quadratic equation. That's the points that it crosses the x-axis, so it's at positive 3, 0, and it's at negative 3, 0. We know from the equation that our y-intercept is at negative 9. We now have our 3 points, and we have a great looking parabola. Sorry for that confusion. I couldn't find the right paper, so that's what you get when you're doing these little videos. All right. Example number 2, we're given a function negative 2x squared plus 7x plus 4. What we're going to do is we're going to go through the steps again, and we are going to determine our axis of symmetry. The way we do that is we take x is equal to, look up above, negative b over 2a. All right. First thing we need to do is we need to figure out that a is equal to negative 2. What that tells us is that our parabola is going to be pointing down. We have a b value in this equation, so b is equal to 7, and c is equal to 4. All right. Plug our values in. We have negative b, which is negative 7, over 2 times a, and a is equal to negative 2. So we get negative 7 over negative 4, which is the same thing as 7 over 4. All right. Next, we're going to determine where our vertex is. And in order to determine what the vertex is, we take negative b over 2a. That's our x component. All right. Which we just whoops, I'm sorry, I'm thinking of the last problem. We'll scratch that out. We take our x component, which we just calculated, is 7 over 4. All right. Now we take 7 over 4 and we plug it into our original equation and evaluate that, and we come up with our new number. And if we do, we get negative 2 times 7 fourths squared plus 7 times 7 fourths plus 4. If you do the math, work it out, takes a little bit of time, you get that your answer is 10.125 or 10 and an eighth if we left it as a fraction. Next, we look at our equation. We know our y-intercept is simply given here. It's at 4. So the coordinates of our y-intercept we write down as 0, 4. Now, for the roots of the equation, we go through and factor this equation, and you can do it by either the ACD method or by grouping. I'm not going to go through step by step how to do that, but when you do factor the equation above, you will get that your two roots, or your solution, is negative 1 over 2 and 0, and your other solution is 4, 0. All right. We're going to go ahead and plot these points, and I'm going to draw some points on the X and Y axis, so we'll have some things to work with. I'm just going to write down through 5. That should be plenty. And then going down the Y axis, I don't believe we need anything because our vertex is way up top. So I'm going to go up 4, 5, 6, 7, 8, 9, 10. All right. First thing we do, we know our axis of symmetry is 7 over 4, which is the same thing as 1 3/4 or 1.75. So we're going to go ahead and draw an axis of symmetry at that number. Now that we have that, we know that our vertex is along the axis of symmetry, and it's at 10 and 1/8. Well, here's 10. We're going to go up a little bit above that. There's 10 and 1/8. We know our y-intercept is at 0, 4, 1, 2, 3, 4. We know our y-intercept is there. So next thing we're going to do is we're going to label our roots, which is negative 1/2 and 0, and positive 4, 0. All right. We have all the information now we need to graph this equation. So what I'm going to do is try to draw a parabola. Hopefully your art works better than mine. There we go. All right. Now that we've drawn our parabola, we can look at it, and we know our domain is continuing in the negative infinity and continuing to positive infinity. So we're going to write negative infinity to positive infinity. Remember, we use interval notation. Okay. Our range, our maximum is at 10.125. Our minimum, we're going down to negative infinity. So we always start with the minimum. We go to negative infinity. We're going to our maximum, which is 10.125. And we use the square bracket because that value is included. We're now finished. As you see, the function is negative, so the graph is pointing down. We calculated the vertex, which is at 1 3/4, 10.125. We put a point there. We solve for our zeros. We have 2 points on the x-axis. We have our y-intercept, and there we go. So that's basically it. Now you need to get out assignment number 14 and work on those problems that are due for homework tonight. Goodbye.